Good morning, students. Today we are going to see with what is collision. What is meant by a collision is it is a common phenomena that happens around us every now and then. We know that it is a common phenomena which happens around us. So, for example, we can say that carom, billiards, marbles, etc. They all come under the collision. So collision can happen between the two bodies with or without physical contact. It's not that the collision can happen only with the physical contact, but it is said that it can happen also without the physical contact. Clear? So this is about what is collision. And next is we are going to see the types of collision. There are mainly two types of collision. They are elastic collision and inelastic collision. Okay, so what are the two types of collision are elastic collision and inelastic collision. First, let us see with what is an elastic collision. In a collision, the total kinetic energy of the body before collision is equal to the total kinetic energy after collision. That is, initial kinetic energy is equal to the final kinetic energy. Then that type of collision is called as a elastic collision. Clear? Total initial kinetic energy before collision is equal to the total final kinetic energy after collision. So we can say that in the elastic collision, the kinetic energy is conserved. Conserved means it is same, okay, it does not change. So total energy, kinetic energy before collision is equal to total kinetic energy after collision. Okay, next is inelastic collision. So what is an inelastic collision is the just opposite of elastic collision. So total initial kinetic energy before collision is not equal to the total final kinetic energy after collision, then that is called as a inelastic collision. Yes, clear? So the kinetic energies, if they are not equal, that comes under the inelastic collision. We can say that the total kinetic energy before collision not equal to total kinetic energy after collision. So that can also be written as total kinetic energy after collision minus the before. Okay, so after collision before collision minus பண்ணோம் அப்படின்னா that gives your loss in the energy during collision. Okay, and that loss is denoted by del of q. Okay, total kinetic energy after collision minus total kinetic energy before collision, that is equal to what? The loss in the kinetic energy, that is denoted by del q. Let us now see with what is elastic collision in one dimension. This question is very important question, important 5 mark it is. Elastic collision in one dimension. For considering with this elastic collision in one dimension, let us consider with the two bodies. Those two bodies have the masses m1 and m2, and that two bodies are moving in a straight line, and that is also moving on a frictionless horizontal surface. So two bodies have the masses m1 and m2 that is moving on a frictionless horizontal surface. These are the two bodies m1 and m2. We are considering before as well as after collision. For before collision, the velocities are u1 and u2. After collision, the velocities become v1 and v2. Okay, so the masses are same, m1 and m2, but the velocities are alone changing. So before collision it is u1, u2. After collision, it is written as v1 and v2. We are writing the masses m1, m2, initial velocities that is before collision u1 and u2. Final velocities is after collision v1 and v2. Let us now write with what is the formula for momentum. General formula for momentum is what? P is equal to m into v. Okay, this is the formula for momentum. Now this we are going to write for the particle m1, and that too before collision. Before collision, what is the velocity is u1. So m1 into u1. Okay, same way for the particle m1, but after collision. So after collision it is v1, so it is m1 into v1. This is for the momentum of the mass m1. Same way, if you are writing the momentum for the mass m2, that is before collision, then we are writing this as m2 into u2, and for after collision it is written as m2 into v2. Now add this both so that we get the total linear momentum. So this is the total initial momentum, so we are writing as pi. When we add this, we get m1 u1 plus m2 u2. So this is p of I. Next is p of f, that you get when you add these two terms. So p of f, which is given by m1 v1 plus m2 v2. Make clear with these two formulas for momentum. Initial we are writing as m1 u1 plus m2 u2. Then for final we are writing as m1 v1 plus m2 v2. Clear? Next is we are going to write equation total momentum before collision is equal to total momentum after collision. So when you equate that both, we get m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now bring m1 term this side and m2 term to this side, so that we get m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Clear with this? Okay, because we are bringing with the one term this side, so we'll be getting as m1 u1 minus m1 v1, which is equal to this side will be getting as m2 v2 minus, and the next term is m2 u2. Bring this m1 outside. So m1, if you are bringing common outside, we get m1 into u1 minus v1. Okay, same way here also, if you bring m2 outside, we get v2 minus u2. So this is the equation which is you are getting when you are comparing the momentum of the initial and the final particle. So make clear with this equation, which is m1 into u1 minus v1 is equal to m2 into v2 minus u2. Clear? Next is we are going to write the equation for kinetic energy. Okay, so kinetic energy, the general formula is given by what? Half m into v square, is it not? So when you write this half m v square for the initial and the final particles of the masses m1 and m2. First, when you consider kinetic energy of mass m1, kinetic energy of mass m1, that is before collision. Before collision you will be writing as u1. So general formula is half m v square, so half m1 u1 square. Next is after collision we will be writing as half m1 v1 square. Okay, next for the particle m2, half m2 u2 square, then half m2 v2 square. Okay, so this is the kinetic energy. Okay, so when you add these terms, so that we get the total energy, total kinetic energy. So k I1, so we have to add this both. So m half m1 u1 square plus half m2 u2 square. Same way when you add this both, we get half m1 v1 square plus half m2 v2 square. Okay, and same way here also we'll be writing that the kinetic energy before collision is equal to total kinetic energy after collision. So we can equate this both. Okay, so we'll be getting the equation as half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. Now take this half common and you can cancel with the half terms. Okay, and same way bring this m1 to this side, and same way m2 we are going to bring it here. Okay, cancelling with all the values of half, and m1 you bring it this side and m2 if you bring it to other side, so that we get the equation as m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Now bring this m1 outside, so that we get u1 square minus v1 square. Same way m2 outside, we get v2 square minus u2 square. Okay, now this is of the form a square minus b square. So when you see here this u1 square, so a square minus b square, so this can be written as a square minus b square formula is a plus b into a minus b. So this can be written as u plus v, u1 plus v1 into u1 minus v1. Same way v2 plus u2 into v2 minus u2. Okay, so this is the equation which you are getting. Now just write this equation, and also what is the equation which you got when you compare with the momentum is m1 into u1 minus v1 is equal to m2 into v2 minus u2. That equation we are going to take it and we are going to divide these two equations. So dividing this equation here, same way here also when you divide, this term gets cancelled, and same way this also gets cancelled. Here also m2 gets cancelled and this. Okay, because this is the equation which you got already, is it not? So u1 plus v1 is equal to v2 plus u2. Okay, so when you arrange this, we can bring this u this side and v this side. So u1 minus u2 is equal to v2 minus v1. So this is one equation, and the other equation you can write is u1 minus u2 is equal to, bring minus outside, so that we get v1 minus into minus, we get again plus here, so minus of v1 minus v2. Okay, so these are the equations which are getting. We can also take one more equation from this. Okay, in this equation bring this v1 here, so that we get the value of v2. Okay, so we get the value of v2 to be equal to u1 plus v1 minus u2. Same way v1, if you are writing, bring these two terms to the other side, so we get the equation for v1. Okay, so using these values of v1 and v2, we are going to substitute, okay, in this equation, because the equation which you have here is what, m1 into u1 minus v1 is equal to m2 into v2 minus u2. So this is the equation which you are taking. In this, substitute the value of v2 here. v2 is equal to u1 plus v1 minus u2. Okay, then again 1 minus u2. Clear? Minus u2 is minus 2 into u2. Yes, now multiply this m1 inside, so that we get m1 u1 minus m1 v1 is equal to m2 u1 plus m2 v1 minus 2 m2 into u2. Clear? Same way here also, we are going to bring u terms all to one side and v terms all to the other side. Okay, so bringing u terms all to one side, so the before equation which we have here is this one. Okay, bring u terms all to one side, so u1 you are bringing here, and same way u2 if you bring here, this becomes minus, and this when you bring it here, this becomes plus. v1 you are going to bring it to other side, that becomes as plus. Clear? So we get the equation to be m1 u1 minus m2 u1 is equal to plus 2 m2 u2 is equal to m1 v1 plus m2 into v1. Okay, now what is the common term here? u1, so take it outside. Same way here the common term is v1, take it outside. Yes, now we need the value of v1 alone. So what we have to do is bring this term down. Okay, so we get m1 minus m2 divided by m1 plus m2 into u1 as it is, plus 2m2 into u2 divided by this term. Okay, so this is the equation for v1. Okay, so we have got the equation for v1. Now if you have to write the equation for v2, the same one, but wherever you get as 1, we have to write as 2. Wherever you get as 2, we have to write it as 1. So we are getting the equation for v2 as 2m1 divided by m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. Clear? So this is about the elastic collision in one dimension. So this is the derivation. So we have got the value of v1 and v2. But after this, we also have the special cases. Okay, special cases is very important. So what we are going to do with this special cases is, we are going to take with these two values of v1 and also v2. So what is the formula for v1? Make clear with this formula, m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. Okay, so this is the equation which we are getting for v1. Clear? Same way, if you take the value of v2, we get 2m1 divided by m1 plus m2 into u1 plus m2 minus m1 divided by m1 plus m2 into u2. Okay, so taking with these equations, what is the first conditions you are going to substitute here is, when the two bodies have the same mass. Same mass is m1 is equal to m2. Okay, so when we take m1 is equal to m2, what is the equation for v1? First we have m1 minus m2 divided by m1 plus m2 into u1, is it not? So here we are having m1 is equal to m2. So இந்த இடத்துல நம்ம m2 க்கு பதிலா m1 substitute பண்ணா m1 minus m1, so that becomes 0. So we are getting this value to be 0. Okay, plus Okay, the next term we have is 2m2. So 2m2 divided by m1 plus m2 into u2. Okay, so this is a second value. So in this also 2m2 as it is. Instead of this m1, we are substituting as m2. m2 plus m2 is again 2m2 into u2 as it is. Okay, this 2m2 gets cancelled, so we get the value of v1 is equal to u2. Because this becomes 0, so we get just v1 is equal to u2. Okay, so we have got the value of v1 here. Same way, if you are writing the value of v2 in this, so v2 is equal to what? 2m2, sorry, 2m1 divided by m1 plus m2. Okay, so this is the first one into what? Into u1 plus m1 minus m2. so m1 minus m2 நாலே நம்ம என்ன பண்ணிடலாம், அது வந்து 0 ன்னு கன்சிடர் பண்ணிக்கலாம். ஏன்னா ஈக்குவலா இருந்ததுன்னா என்னது, மைனஸ் பண்ணும்போது 0. so this term becomes 0 here. Okay, and next is here substitute the value of m2 equal to m1. m2 க்கு பதிலா m1 substitute பண்றோம். so we get m1 plus m1, that becomes as 2m1. so already 2m1, here m1 plus m1 is 2m1 into u1. so this 2 term it gets cancelled, so we get v2 is equal to u1. Okay, so this is a second condition we have got. Clear? So these are the two things of the case 1, which is when the body is having the same mass. So second condition is the masses are equal, so m1 is equal to m2, and also the second object is at rest, that is u2 is equal to 0. so substituting m1 is equal to m2 and u2 is equal to 0, the first equation for v1 is m1 minus m2 divided by m1 plus m2 into u1. here substituting m1 is equal to m2, so inga minus இருக்கிறதுனால இது என்ன ஆகும், இது ஃபுல்லா 0 ஆயிடும். Okay, so this becomes 0. next u2 is equal to 0, so அப்போ இந்த u2 0 ஆகிறதுனால என்ன ஆகும், this also fully becomes 0. so we are getting v1 is equal to 0. Clear? next again m1 is equal to m2, அப்படினால என்ன ஆகும், this term becomes 0. m1 equal to m2, then u2 is equal to 0. here only we have this u2, so this becomes 0. and when you substitute m1 is equal to m2 here, okay, instead of m2, if you write the value as m1, we get m1 plus m1, which is 2m1. so 2m1 and 2m1 gets cancelled, so we get v2 is equal to u1. Okay, so this is a second condition. Okay, so the first condition is m1 is equal to m2, the second condition is m1 is equal to m2 and also u2 is equal to 0. Okay, then the third condition is the first body is lighter than the second body. Okay, so this condition is first body is lighter than the second body, so we are substituting m1 is very much lesser than m2. Okay, so that m1 divided by m2 is less than 0. Okay, so we can say that m1 by m2 எங்கெல்லாம் வருதோ அந்த இடத்துல 0. இது ஒரு கண்டிஷனும், நெக்ஸ்ட் கண்டிஷன் இஸ் u2 is equal to 0. ஓகே, ஸோ அப்போ m1 divided by m2 என்ன பண்ணணும்னா whole equation we have to divide by the term m2. ஓகே, ஸோ v1 எடுத்துக்க போகிறோம், v2 எடுத்துக்க போகிறோம், அந்த ரெண்டு ஈக்குவேஷனையும் ஃபர்ஸ்ட் m2னால டிவைட் பண்ண போகிறோம். the next condition is u2 is equal to 0. clear? so this is the value of v1. Okay, so the whole equation if we are going to divide by m2, so we get m1 divided by m2 minus m2 divided by m2, then here also divided by m2 and here it is divided by m2. clear? now this m2 and m2 gets cancelled, so we get 1. okay, here also we get 1. yes, here also we get m2 and m2, so we get 1. this m2 and m2 we are getting this to be 1. clear? and u2 value is given as what? 0. so we are substituting this as 0, so this full term becomes 0 because 0 into anything is 0. clear? now what is the next condition is m1 by m2 is equal to what? 0. so m1 by m2 0, m1 by m2 0 minus 1 divided by 1 into u1. okay, so 0 minus 1 divided by 0 plus 1 into u1. okay, so minus 1 into u1 is we get minus u1. okay, so this is the value of v1. v1 is equal to minus u1. clear? so we are taking with the value of v1. in the value of v1, each term we have to divide by the term m2, and the next condition is u2 is equal to 0. same way take with the value of v2 and in this also each term we are going to divide by m2. Clear? This also divided by m2. Here we get m2 divided by m2, and this also divided by m2. So all the terms m2 by m2, that is 1. Same way here also m2 by m2 1, m2 by m2 1. Clear? Next condition is u2 is equal to 0. So u2 is equal to 0. This full term becomes 0. Clear? m1 by m2 is what? 0. Okay, and so anything into 0 is 0, this term into this, so this also becomes 0. So we get v2 is equal to 0. This also becomes 0. Here also it becomes 0. So we get v2 is equal to 0. Clear with this condition? The last case is second body is lighter than the first body. So we are considering m2 is less than m1. So m2 by m1 is less than 1. m2 by m1 is equal to 0. So what we are going to do, again taking with the value of v1 and v2, all the terms we are going to divide by m1. Here also we are going to substitute u2 is equal to 0. Okay, first take with the value of v1. So in this value of v1, divide by m1. Okay, so we get this divided by m1. m1 by m1 gets cancelled, so we get 1. m1 by m1 we get 1, and here m1 by m1 we get 1. Okay, and also u2 is equal to 0. So this full term becomes 0. So we have to concentrate only in this term. Here also m2 by m1 is 0. So this becomes 0. This also becomes 0. So 1 minus 0 divided by 1 plus 0 into u1. Okay, so this vanishes. 1 by 1. So we get v1 is equal to u1. Next is if we take the value of v2, taking with the formula for v2, and in that also all the term if you are going to divide by m1, so this m1 and m1 gets cancelled, so we get 1. Here also m1 m1, this term also we get 1. Okay, so this also gets cancelled, and the next condition is u2 is equal to 0. So this full term becomes 0. So we get 2 divided by m2 by m1 into u1. What is the next condition is m2 by m1 is 0. Okay, so this becomes 0. Okay, so 2 by 1, that is 2 into u1. Okay, so this gives your condition for the elastic collision in one dimension. Clear? Thank you.